You know that feeling, right? Your EV range is dropping, flashing red, and the nearest charger on the app seems miles away. And you're wondering, is it working? Is someone else using it?
Oh, yeah, that range anxiety combined with charger anxiety is a real headache for current EV owners
Yeah,
and definitely something potential buyers think about.
exactly. Well, today we're going to unpack this because we're doing a deep dive into a company called Be Charged. They've got this $100 million plan, a whole ecosystem aimed at solving that exact problem with mobile EV charging.
And what's really interesting, I think, is that they're not just trying to add more static chargers. They're fundamentally questioning if chargers need to be static at all. Their whole mission seems to be about, well, reinventing energy delivery using autonomous mobile units.
That's the core idea. So in this deep dive, we'll explore their vision. We'll look at, why they think the current fixed charging network is flawed, how their mobile system actually works, the tech behind it.
The market opportunity, which looks pretty big,
Mm,
and their plans for the future, right?
right. And the goal here is to pull out the key insights for you without getting totally lost in the weeds.
Okay, so let's start with the problem B Charged is trying to solve. They basically argue that our current way of thinking about EV charging, these static stations, it's inherited from like old gas station thinking, combustion thinking.
And they've got numbers to back that up. They point out that, get this, 78% of Americans don't have reliable EV charging access where they live or work. That's a huge number.
It really is. And then there's the time factor. They estimate on average it takes almost half an hour just to get to a station and then maybe another 19-20 minutes waiting for it to be free.
So you're looking at nearly an hour sometimes just for a charge. That's inconvenient.
It adds up, definitely. And then think about the cost to build these things. B Charge quotes $3.2 million on average for a DC fast charging network. Not just one station, the whole setup.
Wow, that's a massive investment. And their argument is, even with all that spending, building fixed stations just can't keep up with how fast people are buying EVs.
Exactly. They believe it can never scale fast enough. It raises that fundamental question. Is a static model the right fit for a world that's increasingly electric and mobile?
It feels a bit like, I don't know, building payphone booths when everyone has a smartphone. Be Charged really emphasizes the contrast with their autonomous unit.
Right. Instead of you going to the energy comes to you on demand, anywhere.
And no waiting lists, theoretically, because their AI predicts where chargers will be needed.
That's the goal. Predictive deployment for zero wait times. Plus, no massive fixed infrastructure costs, just the mobile units themselves.
So it goes from limited coverage, maybe only along highways or in certain city spots, to potentially universal capability.
Potentially, yes.
Yeah.
And instead of maintaining all those individual stations, you have a self-optimizing network of mobile units. They even showed this graph, didn't they?
Yeah, that animated visual. It showed EV adoption climbing steeply, like this, while static charger growth is much flatter, like this. The gap just keeps getting wider.
It really drives home their point about the limitations of the current system.
Okay, so if the static model is obsolete in their view, what's the B charge alternative built on? They went back to basics, didn't they?
They did, asking that fundamental question. Why should energy be stationary at all? It's classic first principles thinking. Let's rethink the whole thing.
So how did they answer that? What's their solution look like?
It seems to boil down to four key parts. First, you need a fleet, a self-expanding fleet, of these autonomous vehicles carrying level 3 fast chargers.
Okay, autonomous mobile chargers.
Second, you need smarts, predictive AI to figure out the best places for these units to be, anticipating demand.
So they're waiting nearby, ready to go.
Pretty much. Third is the user experience, ordering a charge easily through an app, maybe voice commands, or even having the car itself request a charge.
Seamless integration.
And fourth, the big one, scaling. Exponential scaling, they claim, without being limited by needing to build physical stations everywhere.
All right, let's get into the tech of these autonomous units. What are we talking about in terms of performance?
Well, the specs are quite impressive. They're talking 10% to 80% charge in about 17 minutes. That's using 150 kilowatt output.
That's proper fast charging and compatibility.
Universal, that's key.
Hmm.
CCS, CHAdeMO, and NACS, the Tesla standard. So they should work with pretty much any EV out there.
And how quickly can one get to you?
They're claiming an average response time nationwide of just 11 minutes, which is pretty fast if they can maintain that.
Okay. And how many cars can one unit charge before it needs recharging itself?
About 8 full charges per unit. And the whole thing is managed by their own AI, a neural network that optimizes routes, positioning, everything, and it's constantly learning.
They showed that exploded view, too, of the unit itself. Looked complex.
Yeah, it's definitely packed with tech. You've got advanced LFP battery arrays, lithium iron phosphate, known for safety and lifespan, but with their own cell design.
Right.
Then proprietary inverters to handle the power, the connectors for different standards, a whole suite of sensors for the self-driving part, lidar, cameras, etc.
And the AI brain managing it all.
Exactly. The AI charge optimization system. It's a real convergence of battery tech, autonomous driving, and AI.
Okay, zooming out then, what's the potential market size they're looking at?
They're throwing around a big number, $387 billion for the global EV charging market by 2028. A huge pie they're trying to carve out.
And how does their mobile approach give them an edge in grabbing a slice of that?
They highlight some key comparisons. They claim their model has 83% lower infrastructure costs compared to building static stations.
83% lower. That's massive.
It is. They also project they can expand into new markets 11 times faster, and they cite customer satisfaction at 97%.
Which is incredibly high.
And 4.7 times greater vehicle service capacity for every dollar invested. Their framing is pretty stark. This isn't just better, it makes the old way technologically obsolete.
That's quite the statement. They had that growth chart, too, showing their projected curve shooting up way faster than traditional networks.
Right, visually reinforcing that scaling advantage. And apparently they're already up and running in 37 markets, those yellow zones on their map.
With plans for 24 more, the blue zones. So they seem to be moving pretty quickly already.
Yeah, the traction seems real. And the engine behind this, they say, isn't just one thing. It's this engineering convergence.
Right, the three big tech trends merging. Autonomous mobility, energy density, and neural network optimization. Let's break those down a bit.
Okay, so autonomous mobility. They talk about their own navigation system, claiming 99.97% reliability. It uses advanced lidar mapping and is designed for tricky urban areas, different terrains, even bad weather.
So robust self-driving tech specifically for this task. Then the batteries.
Energy density revolution, they call it. They're using modified LFP batteries, lithium iron phosphate, but with changes to the cell structure and advanced thermal management to pack in 2.3 times the energy capacity, getting those 8+ charges per unit.
LFP is generally safer too, right? Less prone to thermal runaway.
That's generally true, yes. Safety and longevity are big pluses for LFP. And then the third piece is the AI.
The neural network optimization. How smart is the system?
Well, it's designed to learn continuously. It predicts demand hotspots, understands usage patterns over time, factors in weather forecasts because weather affects range and charging needs, and optimizes routes based on live traffic. It's meant to get smarter with every charge delivered.
It sounds like these three things are deeply interconnected. The vehicles need the batteries and the smart navigation, and the AI needs the data from the vehicles.
Exactly. That synergy is what they believe creates their intellectual property moat. They claim it gives them about a 7-year head start on competitors.
And they've got the patents to back that up.
Seems so. They list 27 granted patents already, with another 41 pending, covering all the key areas.
Mobile energy delivery, the autonomous charging ports themselves, the AI algorithms for deployment, power management, even secure wireless authorization.
Yeah, it's a comprehensive IP strategy, definitely designed to be a barrier to entry.
Okay, let's shift gears to the money side. How does Be Charged actually make money? And is it sustainable?
This is their economics of inevitability argument. They've set up multiple revenue streams designed to feed into each other, that flywheel effect.
Okay, what are the main ones?
Primary revenue comes from charging itself. Pay-per-use at 0.38 cents per kilowatt, which they say has a 42% margin.
Pretty healthy margin.
Then premium subscriptions, like an all-you-can-charge model, for $99 a month. That has an even higher margin, 76%. And they offer emergency charging, too, for a base fee plus the per kilowatt rate.
So direct charging revenue, but there's more, right? Secondary streams.
Yeah, and this is where it gets interesting. They integrate with car manufacturers, OEMs. They charge them $78 per vehicle per year, and they say they have 17 OEM partners already.
Wow, so the car companies are paying them.
Apparently so. Then there's a platform for businesses with EV fleets, charging $299 per vehicle monthly for managed charging.
Okay, targeting commercial fleets.
Plus, they're selling services back to the energy grid stabilization, earning about $13.7 million annually from that, and they're monetizing the data.
The predictive energy usage data.
Exactly. Estimating $27 million a year just from selling that intelligence. That's data traditional charging networks just don't have access to in the same way.
Okay, so multiple income streams. What about the individual units? Are they profitable?
The unit economics look pretty strong on paper. Deployment cost per unit, around $97,400.
Okay.
They estimate each unit handles about 17 charges a day, bringing in roughly 43 calories per charge on average.
Which pays
A
out.
payback period of just under 8 months, 7.8 months, and a projected 5-year ROI of almost 12x.
That's a very quick payback and strong return if those numbers hold. They had that diagram showing how it all connects, right? The flywheel.
Yeah, the revenue flywheel. Mobile charging feeds data, which enables data services and grid services, which attract OEM partnerships, which drives more mobile charging demand. It's designed to be self-accelerating.
Okay, the tech sounds plausible. The economics look good on paper. But how do you actually manage thousands of autonomous robots driving around charging cars? That sounds like an operational nightmare.
Right, execution at scale is crucial. They highlight 4 key systems they've built for this. First, distributed manufacturing building modular units in 6 different regional facilities, not one central plant.
Spreading it out. Makes sense.
Second, the AI fleet management we talked about, that's handling the logistics, deployment, scheduling automatically. Third, predictive maintenance, using sensors and AI to fix units before they break, aiming for 99.8% uptime.
Proactive, not reactive.
And fourth, a remote operations center. Humans monitoring the network 24/7, ready to intervene within seconds if the AI flags an issue or needs help.
So a combination of automation and human oversight, and they claim they can scale this pretty fast.
They claim they can double the fleet size every 4.7 months while keeping service quality high. That's rapid growth.
Yeah, very rapid. And they have that live dashboard showing current metrics.
Exactly. Things like current fleet size, over 1,200 units when the source was compiled, how many new units are deployed monthly, customer satisfaction scores, average charge times, SLA compliance, real-time visibility into operations.
Okay. So how do they see themselves fitting into the existing charging world? Who's the competition?
They break it down. You've got the legacy infrastructure companies, the big networks, building static stations. Be-Charged basically says they're slow, expensive, limited coverage, building stations like it's 1950 was the phrase, I think.
A bit dismissive, but okay. Who else?
Then there's some minor mobile startups. But Be-Charged argues these are limited, maybe not fully autonomous, shorter range, lack the sophisticated AI, and crucially, the IP protection.
So how does Be-Charged position itself against those?
They argue they're defining a whole new category. Autonomous mobile fleet, neural net optimization, built for exponential scaling, and wrapped in that extensive patent protection.
That patent wall again?
Yeah, they emphasize that 7-year competitive moat. They break down their IP. 8 patents granted for the autonomous navigation part, 12 for mobile power delivery, 7 for the AI optimization, plus many more pending.
It's a significant portfolio, and they feel they have first-mover advantages, too.
Definitely. Network effect, they already have almost 900,000 active subscribers using the service. Data advantage learning from over 6.7 million charging events. Manufacturing scale with those regional facilities, and that claims 7-year tech lead.
Okay, so let's look at the overall picture then. Financials, growth. Where are they now, and where do they expect to go?
Current numbers cited are $100 million valuation, $42 million in annual recurring revenue, 73% gross margin,
This 73% is very high.
and 211% year-over-year growth. So rapid expansion already happening.
And the future projections.
Ambitious, to say the least. By 2029, they're projecting $1.7 billion in annual revenue.
Wow. Billion with a B.
Maintaining margins over 70%, expanding to 214 markets, and operating over 8,700 autonomous units. They frame these projections almost as mathematical inevitabilities based on their model's performance so far.
That's bold. But they have that dashboard showing the curves heading that way.
Right. The financial projection dashboard illustrates the revenue growth, margin expansion potential, and the unit economics driving it all.
Of course, none of this happens without the right people. Who's running the show at Be-Charged?
They really emphasize the team's background. World-class leadership, they say, with experience from places like Tesla, SpaceX, Apple, Google, high-profile tech companies.
Any specific names mentioned?
They highlight the founder and CEO, Anthony Okarabito. Apparently, he was a lead in Tesla's supercharger network expansion. Strong engineering background, holds patents himself.
So someone with direct experience in building large-scale charging infrastructure, but now doing it differently.
Exactly. And other key execs reportedly come from similar backgrounds. CTO from Tesla, COO from Amazon Logistics, CFO from SpaceX. People used to complex, large-scale operations and cutting-edge tech.
It sounds like they believe the team is a major asset.
Definitely. And it's not just about the charging service itself. They talk about building an entire ecosystem.
Right, the ecosystem play. What does that actually mean?
It means integrating deeply with other players. They mentioned 17 deals with car manufacturers, including the top 5 globally.
So Be Charged could become like a built-in feature or recommended service for new EVs?
Potentially, yes.
Yeah.
They're also integrated with 42 fleet management platforms. Think companies managing delivery vans for Amazon, Uber drivers, corporate fleets.
Making it easy for businesses to use their service.
And partnerships with 7-city deals mentioned for things like emergency power or supporting electric buses, plus 3 contracts with power grid operators.
Grid operators, how does that work?
Using their mobile battery fleet for grid stabilization, managing peak load. That network diagram they showed really visualized how interconnected they aim to be.
It seems like there are benefits all around if this works.
That's the idea. For OEMs, less range anxiety for customers, lower infra costs for them. For fleets, no charging downtime, predictable energy costs. For cities, flexible power, no fixed costs. For grid operators, load balancing, mobile storage, it creates these reinforcing loops.
Okay, so that's the current business and the near-term growth. What about further down the road? What's the long-term vision?
They're definitely thinking beyond just charging cars. One big area is bidirectional grid support, turning the whole fleet into a giant distributed battery.
A virtual power plant, essentially.
Yes, it is storing excess renewable energy, feeding power back to the grid during peak demand. Then there's autonomous emergency response, rapidly deploying power after disasters.
Critical infrastructure support.
Right. And expanding to off-grid areas, rural communities, developing markets, tourist spots, places where building static chargers might never make economic sense.
Bringing energy access anywhere.
And the ultimate vision seems to be this idea of a self-replicating network. AI driving autonomous expansion, building new units, deploying them predictively, all with minimal human oversight, constantly improving itself.
Wow. That's
Yeah.
quite a future they're painting.
It really is. Their core message boils down to this. Static charging was just a temporary phase, a transition. They believe they're building the inevitable future of energy delivery.
Not just a better charging company, but the next evolution.
That's how they're positioning themselves, yes.
Okay, so wrapping this up. We've dug into Be Charged's view on the flaws of traditional EV charging, the scarcity, the time, the cost, the scaling issues.
And we looked at their alternative, this innovative network of autonomous mobile superchargers driven by AI and advanced batteries.
We covered the tech convergence making it possible, the strong economic case they're putting forward with those unit economics and diverse revenue streams, and their experienced team.
And that ambitious future vision, going beyond just EVs into grid services, emergency response, and even off-grid power.
What really strikes me is the potential shift this represents. If energy can truly come to you on demand anywhere, it changes the game for EV adoption, removing a major barrier.
Absolutely. It promises convenience, accessibility, and a scalability that traditional infrastructure might struggle to match.
And it makes you think, doesn't it? If you can have energy delivered autonomously, on demand, what else could that enable? Beyond cars, what other parts of our lives or infrastructure could that kind of mobile energy transform?
That's the provocative thought, isn't it? What possibilities open up when energy itself becomes truly mobile? Definitely something to ponder about this potential future of energy delivery.